Alright, on to question 2C from practice exam 2. This is still the school bus problem where we're looking at students and school buses. Now we're moving on to how a particular school handles the bus assignments. So we have this new object, so a new class called a school transport that handles the assignments for a given school. So in this object, in the class that's being defined for a school transport object, it has an array list of school bus objects. So as you see in your code there, they have this private list of school bus objects and they call the list buses. So we want to refer to all the buses at the school, we refer to buses. That's the name of the list. So our task is to write the enroll method for this class. So in the same class we have access to the buses. Method tries to find a bus on which it makes the most sense to place a new student. So first off, the bus can't be full. If the bus is full, there's no ability to put a new student on there. So if the buses that are not full, it looks for a student who's already enrolled, so they're already on the bus route, who lives on the same street, and they need to be as close as possible, the closest student to the new student. And the way we figure out if they're closest or not is we're going to be using that distance method from part A. So whether or not we actually understood the method or actually got the code completely correct, we can assume it works as it's supposed to. It finds the distance between one student and another student. And then we simply want to find the student on the same street who has the smallest distance, the minimum distance between the new student and the students we're scanning through. So check all the students on the buses that are not full. If we find one on the same street, closest one, then that's the bus we want to put this new student on. Okay. So if we find it, we place the new student on the bus and we return true. Returning true indicates that we found a bus and the student is now enrolled and on that bus. Otherwise, suppose we don't find any other students with the same street, or all the buses are full, then we would return false. Okay, so returning false indicates that, as it says here, indicates that the bus placement decision is left to the school's transportation manager, and then it says complete the method below. So in other words, if we can find it, if our program works well enough, if it can find a street with a bus that's not full, excuse me, let me back up. If you can find a bus that's not full, with a student on that bus that lives on the same street, and that student is the closest living, or has the smallest distance, is the closest to the new student's house, then that's the bus we want to put the student on. If we can't find such a bus, then if we were to put it in terms of like our school, be like, all right, Mr. Gossett, you're in charge of buses, our program doesn't find an accurate bus for this student, you just make the best decision you can. Okay, you figure out what is best for this student. So we're going to get started with our method. Again, this was just part of the code that was written for us, the list of buses, so we can refer to that. So the method is public boolean returning true or false, whether or not we actually enroll the student. And then they take as a parameter this new student, and we just refer to that one as student. Okay. So go back through the comment that's written above this method. Okay, you don't see it on my screen, but you can see it on your paper there on page 179. It says that this method looks in all the buses for someone whose bus is not yet full and who lives on the same street. The closest to student, to our new student here, in terms of distance defined for these student objects. If found, adds the student to that bus and then returns true, otherwise returns false. So, a couple things we need to know. We need to keep track of, if we find several students, we're going to need to keep track of what the smallest distance is between those students and which bus we're referring to. So what I'm going to do is I'm going to make a temporary reference for a school bus here. So remember, school bus is a class. We can build a bus or refer to a bus. So we're trying to find the best fit. And instead of just saying best fit, we'll call this like best bus or something like that. So the best bus that works with the current student, and we're going to start it off equal to null. Okay, like there is no best bus right now. Okay, but if we find one, then we'll change this and refer to whatever bus we see in the list that it matches up with. And then I'm also going to make an integer variable here to keep track of the distance, because we're going to need to know what's the smallest distance between those two, and we're going to need to refer to that distance throughout. So I'm going to say int min distance. Makes enough sense. And I need to set this to some really large value So if you remember, if two houses were not on the same street, what was the largest possible distance that could be returned from that distance method? If you have to look back at part A, but it said that if you have two houses on different streets, the distance that is always returned for those is a sequence of 5 nines. So the distance would look like 99,999. So if that's set to our minimum distance and we find any student on the same street on a bus that's not full, if we find the distance between our new student and that student we identify on the bus being on the same street, then that distance will be smaller, so we will update this minimum distance. And then we will, wherever that minimum distance occurs, whatever bus that student is on, we're going to say best bus equals that kid's bus. Okay? And we're going to go through all the buses and try and figure this out. So we're going to say 4, and we're going to navigate through each bus on the list. So we're not changing buses here. We're just accessing information about the buses. So I'm going to say use a for each loop here. For each school bus, I'll call it B. In our list, now what's the name of our list? It's called buses. So go through each bus. All right. Now, what's the first thing I want to check about that bus? First thing I want to check is this bus full? If this bus is full, there's nothing I can do. Even if there is a student who lives right next door, we can't put them on the bus. So what I'm going to do is I'm going to check and see if that bus is full. If you remember, buses, a school bus object has an isFull method. Again, even if I didn't get that to work in my code, I can assume it works like it's supposed to based on the description in part B. The method returns true if there are no vacant seats. If it is full, returns false if it's not full. So if the bus is full, I don't want to do anything, but if it's not full, so I'm going to say if B dot is full, if it's not true, so if that is not full, okay, now I don't need to say equals true here because this returns a boolean. This either returns true or false. So think about this. I only want to do something if the bus is not full. So I'm going to say, so is full returns true if the bus is full. So by putting a not in front, then that would nullify this statement and we would skip it. But if it's not full, that returns false. So the not operator out front would change that to a true, which means, oh, it's not full, that's when I want to execute this. Okay, so hopefully that makes sense. If it didn't, feel free to ask me questions about that when you see me tomorrow or later in class. So if it is not full, if there is space on that bus, what do we want to do? We want to look at the students on that bus. We want to see, does anyone live on the same street? Okay, if they do live on the same street, then we want to see, is your distance between you and this new student smaller than our minimum distance? So the first time we find a kid on the same street, we know that their distance is more than likely, I don't think we're going to have house numbers in the hundreds of thousands, more than likely that minimum distance is going to be shrunk. So I'm going to say, if, let me back up. If the bus is not full, we're going to need to check each student on the bus, right? Like we can't just pick one random student and say, oh, you're not on the same street, and go to the next bus, because maybe there are some who are on the same street, some who are not. So I need to go through all the students, and I'm going to do that using a for loop as well. Again, I'm not going to change the individual students on the bus, just want to access their information, so I can use a for each loop. So for each student in the current bus, which is stored as B, notice that notation there. Each bus is called B, and then I want to go to each student on that bus, which is called B. So now, go to a student. I want to check and see, do you live on the same street as the other one, right? So how am I going to know that? Well, if they're on the same street, then I'm really only concerned with the distance. Because if they're on the same street, then their distance is going to be smaller than this distance right here. Correct? So what I'm going to say is I'm going to say if the distance between you, current student, I'm going to use the dot notation here because remember students have this distance method. So I take one student, say dot distance, and as my parameter, give the other student. Well, let's compare it to our new student. If they're on the same street, it's going to return the difference in their house numbers. If they're on different streets, it's going to return the same number up here. Okay? So if it gives me an actual distance that is smaller than that number right there, than my current minimum distance, then that means I found a student who's closer. Okay? So if I found a student who's closer, whose distance between the new student and them is smaller than the current minimum distance, I want to update a couple things. That means that I want to first update my minimum distance, because now I have an actual distance that applies, or a smaller distance than I saw before. So I'm going to call that same method. That may be kind of hard to tell. That is a lowercase s, not a capital S here. So I'm referring to the student object there. And what I want to say is, after I change the distance, that means I found a student on the same street who is closer than all the other current students that we've seen before. So now I want to say, okay, I found a bus that we could put this kid on, because this bus must not have been full if I've reached this far in the code. So now let's go ahead and say that this is the current best bus. So the best bus is going to refer to the current bus we're looking at, and what are we using to keep track of each bus? We're using the letter B in this for each loop. So whatever the current B value is, that's what we're going to set best bus equal to. Okay, so maybe B, we have reached bus 10, so now best bus is going to equal 10 when we come down here. All right. So we've gone through. We've checked to see that the distance, is it this student closer than any other students we've seen so far? If they are, adjust our distance, change the bus reference, and then go on to the next student. See if we can find another student closer. Once we reach the end of the bus, all the students on the bus, then we want to go to the next bus. So then we kind of escape out, and we are now in this, back to this for loop. Go to the next bus, go to the next bus, check all those students, go to the next bus, check all those students, so on and so on. And again, we're only checking the students if that bus was not full. Okay. So we've gone through all the buses, gone through all the students. We have an accurate minimum distance, the closest student to the new student on the same street, and we have a bus reference. So all I want to do is I want to, if I found a bus, because remember, there is a possibility I could have gone through all the buses and they were all full, or no student lives on the same street as this one. If that happens, then my minimum distance is still going to be this. I will have never set best bus equal to an actual bus. It's still going to be null. So can I actually add a student to this null bus? And the answer is no. So what I need to do is to add in some little safety net here to double check that we actually found a bus. And to do this, I could say if the best bus, if I found anything, if it's no longer null, so if this does not equal null, then that means I have found a bus that works. It wasn't full, had a student who lived pretty close on the same street. So what I want to do is I want to add this student, we're just referring to this student, to the current bus. So I'm going to say go to this best bus, dot add. Remember, school bus inherits all the methods of an array list, including the add method. So best bus dot add the current student. Then we want to return true that this kid was actually enrolled on that bus. Okay. So if we find any bus with this kid who's on the same street and that bus is not full, we add them. We return true that they are enrolled. The only time we return false is if there was no such bus, so that would be the else statement here. Okay, and remember, anytime we have an if statement where there is a return statement inside, we don't even need the else, because if this is skipped, we know we're jumping down here. So the only thing left, I would say, is return false. So if we don't make it in here, if we did not have a bus, if best bus was still stored as null, then we just want to go ahead and return false. We couldn't find a bus. Mr. Gossett, it's your job. Okay, you take care of it. So that wraps up this question. A lot of code, it seems like. Really, it's not too many lines. We just have several sort of nested statements here. If you look at this, we got a for loop with a conditional inside of that, with another for loop inside, with a conditional inside of that, and we finally only have really 2 lines of code where we update the distance and update which bus we're referring to as the best bus. Okay, so may look a little complicated, may have seemed a little complicated, but hopefully it at least makes a little more sense to you, understanding what we're doing, where we are navigating through a list of objects where each one of those objects has a list in of itself. So this is kind of getting into that inception concept, right? Where you go into one zone, so to speak, and then you can carry over into another zone, so a list of lists and things like that. But pretty interesting problem, very applicable. It seems like this definitely seems like it could be something a school would actually use, and that's what's nice to see is as we go through these problems, we see programs that actually seem useful. That's the big takeaway, how powerful these programs can be, and handling something as simple as, oh, we have a new student, which bus do they go on? And being able to understand which would be best in those situations. So that answers this question. Hopefully it makes it more sense. If you still have questions, feel free to leave a comment, send me an email, or talk to me about it in class or in a review session. And if you're done with this, go on to question number 3.